Welcome to Pharma E-Class. I am Dr. Tahir Nizami, Associate Professor at Smriti College of Pharmaceutical Education, Indore. In our series of UV visual spectroscopy, our today's topic is chromophore and auxochromes. Before studying further about instrumentation of UV spectroscopy and about various shifts in UV visible spectroscopy, we have to understand two important terminologies regarding UV visible spectroscopy, which are chromophore and auxochromes. These are some substances which affect the absorption of substances in UV visible range. Let us understand one by one. What is chromophore? Now, chromophore, as name suggests, is a word which is a substance which impart color to any substances. So, chromophore are covalently bonded molecules, moieties, which are attached to any organic compound and which is responsible for absorption of UV radiation in UV visible range. So, basically, we can say that chromophore are those chemical moieties which when attached to any chemical substances, they absorb the UV radiation and they can increase the lambda max of the compound. And these compound, when attached to any chemical substances, they themselves start absorbing UV radiation and increase the lambda max of compound. We can classify chromophore into two major categories. Number one, chromophore with pi star transition. Example are alkenes and alkynes. And chromophore with n pi star transition. Example are acids and azo compounds. So, chromophore which have tendency to increase the lambda max of compound, and they show transition from pi electrons to pi star electrons transition. So, they are type 1 chromophore, and example of alkenes and alkyne. It is because the fact that alkenes and alkynes are highly unsaturated compounds and they have pi electrons in which pi orbitals in which pi electrons are present, and these electrons absorb the UV radiation and they go for excitation. In last video we had discussed about various electronic excitations in UV visible spectroscopy, and we have studied that the sigma star excitation requires larger energy as compared to pi star or n pi star transition. Next type of chromophore is chromophore with n pi star transition. That is, non-bonded electrons are excited to pi excited state, and the example are acids and azo compound. So basically, this is the concept of chromophore that they, when attached to any chemical substance, they have tendency to increase the lambda max of compound. The advantage of studying this chromophore and auxochrome here is because in next video we are going to study about various type of shifts which are seen in UV visual spectroscopy, like red shift, blue shift, hypochromic shift, hyperchromic shift, etc. In that we will discuss the application of these chromophores. Now let us discuss what are auxochromes. Auxochromes are just like a type of organic substances when they are attached to any substance. They do not show any specific color or absorption when separated, but when combined to any chromophore or attached to any chromophore, they increases the absorption wavelength, that is lambda max, towards longer wavelength by formation of new chromophore. So the concept is very simple. Unlike chromophore, they do not have any color, they do not have tendency to impart any color. When they are in separated form, they do not absorb any type of UV radiation. But when they attach to any chromophore, they increases the lambda max. So just like chromophore, auxochromes are also compounds which increase the lambda max of compound when attached to any organic compounds. Chromophore have tendency to impart color. Auxochromes do not have tendency to impart color, but auxochrome themselves do not absorb UV radiation when they are separated form. Neither they show any color when they are in separated form. But when they are combined with chromophore or attached with any chromophore, they increase the lambda max of any compound. They increase the UV absorption radiation, and they shift the lambda max towards longer wavelength. Or in case of vibgyor, we can see that visible light can be classified as violet, indigo, blue, green, red, orange and yellow. So those compounds which increase the lambda max are shift the lambda max towards red part, that is higher wavelength. So auxochromes and chromophores are the two concepts which we will discuss here. Like we studied the example of chromophore, there are some example of auxochrome as well, alcohols, amines, ethers, amines and SH group. These are all example of auxochrome. Let us take one very good example to understand the concept of auxochrome. If we take a reaction of benzene and amine, we know that benzene have lambda max of 255 nanometer. When it react with amine, it will form aniline, and the aniline, the lambda max of aniline is 280 nanometer. So we can say that when this auxochrome is attached to this benzene, whose lambda max is 255 nanometer, now to form aniline, the lambda max of aniline shifted from 255 nanometer of benzene to form 255 nanometer to aniline whose 280 nanometer. So here NH2 plays a role of auxochrome to increase the lambda max of benzene by forming aniline. So NH2 is a auxochrome. Now this is all about auxochrome and chromophore. Now let us discuss about various factors affecting absorption of UV visible spectroscopy. There are basically 4 factors which affects the absorption pattern. Number 1 is presence of absorbing compound. Number 2 is effect of solvent. Number 3 is effect of temperature, and number 4 is effect of presence of inorganic moieties. So in first case, effect of absorbing compounds, we have already discussed about chromophores and auxochrome. That is, there are some organic substances which when attached to any organic compound, they increases the lambda max, they tendency to absorb UV radiation. So presence of absorbing compounds like chromophore and auxochrome can increase the lambda max of compound. Next is effect of solvents. Now solvent plays very important role in UV visible spectroscopy. In last lecture we have studied that alcohol, methanol, ethanol, water, they absorb in the range of 165 to 170 nanometer, which do not affect the spectral analysis in UV visible spectroscopy. But there are some solvents which absorb UV radiation in UV visible range, like benzene, which have lambda max of 255 nanometer, like chloroform, which have lambda max of 265 nanometer, like chloroform, which have a lambda max of 240 nanometer. So since these solvents absorb UV radiation in UV visible range, they show a marked effect in UV visible spectroscopy. So that is why solvent cutoff studies is required, and the presence of this solvent can affect our spectral analysis. So presence of such solvent is also affect the absorption of compounds. Next is effect of temperature. It is well known fact that lower the temperature, greater will be the absorption, and greater the temperature, lower will be the absorption. So for ideal condition for spectral analysis is the temperature should be low so that the maximum absorption can be seen. As we increase the temperature, the lambda max will decrease, absorption of UV radiation by compound will decrease. This may be due to degradation of compound by higher temperature. Next, the presence of inorganic substances. Just like chromophore and auxochrome are organic substances which increase the lambda max of our substance when attached to these compounds. Inorganic substance also, presence of inorganic substance also increase the lambda max of any compounds. We can classify inorganic compounds into 2 major categories, like complex inorganic compounds and simpler or single inorganic compound. Complex inorganic compounds, example chromium ion, chromium oxide, CrO4, manganese oxide, MnO4 2-. Simpler organic compound, example Ag, Au, etc. So presence of these substances can also increase the lambda max of compound. So basically these are the 4 factors which affect the absorption of substance in UV visible spectroscopy. Number 1 is effect of presence of absorbing substances. Effect of solvent, effect of temperature, and effect of inorganic substances or inorganic moieties like chromium oxide, manganese oxide, silver and gold. So in this lecture we have studied that what are chromophore, what are auxochromes, types of chromophore, examples of chromophores, example of auxochromes, example of auxochrome which shows the increase in lambda max, and we have also studied what are the various factors affecting absorption in UV visible spectroscopy, which are presence of absorbing compounds like chromophore and auxochrome, effect of solvents, effect of temperature, and effect of presence of inorganic substances. In next lecture, we will discuss about various type of shifts in UV visible spectroscopy like red shift, blue shift, hyperchromic shift, hypochromic shift, and also we will discuss about the application of this auxochrome and chromophore and their role in chemical shifts. Hope you have understood this lecture well, and see you in next lecture. Thank you.